Many of you may not be familiar with the TI-84 graph calculator or the TI-83. They are essentially the same calculator, so if you have either one, you're in good shape. They are the recommended calculators. I do not have emulators for other types, even other versions of Texas Instruments calculators. Certainly not Casios or HPs or any other type of graphing calculator. So if you have one of those, I'm sorry to say you're a little bit on your own. You can reach out to me individually and I will attempt to help you, but I am not familiar with those calculators. So the 83 or 84 is the best choice. They're probably the ones, if you ever were in high school and they lent out calculators or gave them out for you to use, that was likely the kind that they had to lend out to you. So the operation of the calculator is fairly simple. The layout of the buttons is the same whether you're looking at a TI-83 or a TI-84, whether it's color or black and white. Just the screens may look a little bit different in places, but the layout of the buttons, where you were going to find everything, and the basic function of the calculator is still the same. So you have your typical numbers down here, 0, 1 through 9, decimal, the negative sign, your 4 basic operations, plus, minus, times, divide. Please note there's a difference between subtraction operation and making something negative. These two buttons are very different. And if you use the wrong one, you may get an error message, or what you're trying to do may just not even work at all. There are other things that we will use more throughout the semester, but for now we're just looking at some basics. Another very important thing, you'll notice that above many of the buttons there is a word in blue and a word or letter in green. These are color-coded to the two buttons in the upper left, second and alpha. They work a little bit like the shift button on a keyboard for a computer. To access the blue on top of something, you have to press the second button. So for example, if you wanted to do a square root, that is above the x squared button in blue. You would have to type second. When you do, on the newer calculators, you'll see an arrow icon appear up here. In the older calculators, the flashing icon on the main screen will actually just turn into an upward-facing arrow, much like this. That indicates that when you press a button, it will do the blue object above it. Now, it works the same for the alpha. If you want to type any of the letters of the alphabet or access any of the commands or symbols or letters that are in green, you have to first press the alpha button. When you do, you will see the icon changes to a capital letter A. You can press either one of them again to toggle it off. So, basic functions of the calculator. Now, a lot of what we use the calculator for is going to include the graphing. So, being that this is a graphing calculator, that is one of the most basic functions that we need to take a look at. These 5 buttons along the top here, right underneath the screen, those are the main 5 buttons that are used when you're dealing with a graph. Obviously, you still need the numbers and whatnot below to type in the equation, but these buttons up top are what we will use to adjust the settings and to accomplish certain things with the graph. Now, the calculator can't just graph anything. You need to tell it what to graph first. So we're going to start on the leftmost side by pressing Y equals. Now, if you happen to have a color calculator, yes, there is the ability to have different graphs show up in different colors, which will make them easier to distinguish. It is possible to actually change the colors, but that's not something we're going to need to really worry about here. Here's where you're going to type in the equation that you want to graph. Now, the calculator can graph many equations at once, up to 10. We're only ever going to graph 1 or 2 at a time at the most. However, it is very useful perhaps if there's an equation that you want to graph and then maybe you want to come back to it later on. It is possible to deactivate the equation but leave it typed in so that you can come back to it later and reactivate it when you want it, so you don't have to clear it out and retype it every time. Now, before I go too far, some of you guys will invariably have this problem. It happens fairly often. Maybe you're using a calculator that belongs to your friend, or maybe you lent it out to your friend and now you got it back. Maybe you just put it in your bag and forgot to put the cover over it. And while it was in your bag, buttons got pressed, things happened. These three things at the top, plot 1, plot 2, and plot 3, those are something that is used in statistics. So we're not going to be using it in this class. But if they are active, that could be a problem, because the calculator will try to graph something that isn't there, or if it is trying to graph something and there is data for it to graph, but it doesn't fit on the graphing window, then there will be an error message. So those things just tend to cause trouble. You can tell if they are active because you will see it highlighted in a black box. In general, on the calculator, if something is highlighted in a black box, it means that that is an active thing for the calculator. It's trying to actually do that. So if you happen to ever see these three things, any of them at the top, highlighted in a black box like this, all you have to do is use the arrow buttons to move your cursor onto it until it's flashing, and then press the enter button, and that will toggle it off and remove the highlight. So that is one of the most common things that causes errors when people try to graph, in my experience. However it is that those things get turned on or activated, they just do. All you have to do is just make sure you go in and turn them off. Now, we're going to start with graphing something fairly basic. Nothing too fancy here. Now, when you graph something, note that it is, the button says y equals. All of these are in the format of y equals. Anything we graph has to be solved for y. Fortunately, as we already saw with functions, every function can be solved for y. So that's not a problem for us. Most of the time, if we're dealing with a function, it already has been solved for y. It reads f of x equals. All we have to do is type in the expression. So let's do something simple. There's a button here that we use for the variables. It says x comma t comma theta comma n. Yeesh. Well, as it turns out, there are other ways to graph things besides the rectangular coordinate system. That is well beyond the scope of this class. You do not need to worry about them. As far as we're concerned, this is the X button. If you press this button at any point this semester, it will simply type in X. You can, of course, use the alpha button, and down here on the left, you can find a green letter X. You can do it that way, but it's annoying to have to hit alpha first and then come down here. It's much easier to just type this. So let's do something simple. Let's just do a basic parabola. X squared minus 5. Something very simple. Now, you might notice here that my calculator typed a little 2 up there. All of the 83 calculators would do this too if you use the x squared button. The newer calculators tend to make things look very mathy. The older calculators tend to not do that as often. So there's always another alternative when you're doing other exponents, and that's this exponent caret over here. However, when you use that, keep in mind it's going to make things look a little different. Now, in my case, on the newer calculator, it actually made a little blank box up there for me to type in the exponent. If you have one of the older calculators, you won't get that. You'll actually see it type this on the screen. All right, so let's go back to our regular function, x squared minus 5. Now, we can always just simply press the button that says graph, and it will take us directly to the graph. The calculator tends to remember stuff that you've done. Like, for example, if you turn your calculator off and then turn it back on again, this equation will still be typed here. So sometimes we adjust the way we set up the axes. Like, we might normally like to have them centered on whatever, whether we're doing it by hand, we want them kind of centered on what we're doing. But sometimes we want to see more of one quadrant and less of another quadrant. So we sometimes adjust how we set up the axes. You've seen that in some of the videos that I've shown you on YouTube with some of the graphs. So we can always do that, but I think it's usually a good idea to start with resetting to the standard window. Now, there are several ways to do this. First is this window button. In here, we can change the settings of the window. We can manually adjust them. The standard viewing window goes from -10 on the x-axis to +10 on the x-axis, and on the y-axis, -10 to +10. The scale on the x-axis is by ones, meaning it will place a tick mark at every whole number. Same thing for the y-axis. These are actually not all that important. They can be changed, of course, to make the graph look a little nicer, to make it a little easier to read, but they're not actually crucial to graphing. The x min and max and the y min and max are the important ones. There are a few other things down here that you never will need to worry about. This x-res, this triangle, or actually delta x, and this trace step. You will never ever need to worry about them. Just don't even bother. The only ones you'll ever have to deal with are up here at the top. The x min and max, the y min and max, and if you choose to, you can adjust the scales as well. There will come a time very soon where we will do some manual adjustments, but for now, anytime we're graphing a brand new function, a good idea is to go to the zoom button. And choice number 6 down here, Z standard. That will take us to the standard viewing window. That's always the way to go. There's a lot of other options in here that you'll probably never use. If you ever take a statistics class, you might use this one down here that says zoom stat. But really, the only one you'll ever use out of this is the standard window. The rest of them are, it's better to adjust the window manually, because these things, especially the zoom in and out, which seem like they might be a good idea, they actually usually aren't. Because more often than not, the adjustments we want to make are only in one direction at a time. These will adjust all 4 directions, and sometimes we'll adjust them more than we wish. So they're really not a good idea. Zoom standard 6 down here is the only one we really want to use. Now, you don't have to scroll down to it. You can actually just press the number 6 on the calculator, and it will activate that, and it will take you directly to the graph, where you will see it graph your function. We'll always graph from left to right. If you are graphing multiple equations, it will always graph y1 first, then y2, then y3, and so on. So pay attention to the order of the graphing, especially if you don't have the color calculator. The colors make it easy to tell the graphs apart, of course, but if you don't have the color calculator and you're graphing more than one thing, it can be difficult to tell them apart. So it helps to actually watch the screen while they're graphing. But that's the basics of just typing in an equation and graphing it. You literally just go to y equals, type in your equation, go to zoom and choose choice 6, and there you are. Now, there are times that the graph that we're looking at isn't, this viewing window isn't really appropriate. And again, this viewing window goes from -10 to +10 along the x-axis, and from -10 to +10 along the y-axis. Sometimes that's not appropriate for what we're looking at. Let's go try a different function here. So go back to y equals. Now I want to keep the x squared minus 5. So I'm going to put the cursor on the highlighted equal sign and hit enter to toggle it off, much like we did earlier with the stat plot. So now that equation will stay there, but it's inactive, meaning the calculator won't graph it. So it's there. I don't have to type it again. If I want to come back to it later, all I have to do is reactivate it. Let's look at something else here. Let's try a slightly higher degree polynomial. Let's do x cubed. So again, there is no cube button on here. We'll have to use the exponent caret. Now, for those of you with this, whose calculators type it in this kind of mathy way, pay attention to the cursor. That cursor has a little right arrow on it. You need to press right to get the cursor out of the exponent so that you can type the next thing. So let's do x cubed minus 2x squared minus 15x. Now, again, this equation is active. The first equation is not. Let's again press the zoom button and choose choice number 6, zoom standard, and watch as it graphs our function. That doesn't seem like the best picture. I mean, it doesn't seem like we're seeing all the details that are important. Like, if we're watching our graphs, it goes up this first branch, and then I would imagine somewhere up above, it peaks and drops back down. And then, again, it's going to bottom out and come back up. It would be nice if we could see those points. Now, we can, but we just need to adjust the window. The thing is that it peaks higher up than our window goes. Our window is only going to 10. It peaks somewhere higher than that, maybe around 15 or 20. Not too much higher. I mean, it doesn't look like it goes that much higher before it peaks, but certainly a little bit. So we can manually adjust the window. We're going to, again, press the window button. Now, what we want to change is the top of the graph. That's on the y-axis, and it's the maximum. We can clear this out and type in any number we want here. We don't want to go too big because, again, it didn't look like it needed all that much room before it peaked out and dropped back down. So I'm going to try something like 20. Now, the thing is that this is just trial and error. There's no right or wrong answer here. It's about what the graph looks like and if we're comfortable with it. So I'm going to try 20. If I don't like it, I can always come back in and change it. Now I will press the graph button and watch as it graphs the function again. Well, sure enough, now I can see that peak. I'm pretty satisfied with that. It's not right up at the edge of the screen, which, I mean, even if it was, we could still see it, but we can certainly see it clearly defined there. I'm pretty satisfied with that. Note that we have a lot more tick marks on the y-axis, by the way, because now it's going from -10, -9, -8, and so on to 0, and now it's got to go all the way up to 20. So we're trying to fit a bigger section of the y-axis onto the screen, and that kind of squishes it together and gives us more tick marks. That's where you might want to adjust the Y scale. We'll get to that. Now, we also want to adjust the screen to see what's going on down here because it looks like it should bottom out down there, but it looks like it's going to have to dip down kind of far. So we went up to 20 on the top. We could try 20 on the bottom and see how we feel about it, and if we don't like it, we can always go back and change it. So I'm going to, again, go to the window button. I'm going to clear out the Y minimum, and I'm going to go with -20. Again, please note the difference between the subtraction and the negative. If you say the word negative, you press the negative button. If you say the word minus, you press the minus button. So let's take a look at that and see what we think. Maybe that's far enough, maybe it's not, maybe we need to make an adjustment. Well, certainly we need to make an adjustment. It looks a little bit better. Looks like it's not that much further down before it bottoms out now, but certainly we need to go farther. look now at the tick marks on the y-axis. We're getting a lot of them. So let's dip down further. Now, I'm kind of the belief that I'd rather make a bigger jump than I think I need, a little bit bigger jump, and then maybe I can tweak it from there. So I think if I went down another 10, if I went to -30, that probably wouldn't be far enough. I'd rather jump a little bit further. So I'm going to make this -50 and see what I think about that. Now, before I go back to the graph, I want you to consider now, we're now covering a really big section of the y-axis, and I'm trying to stick a tick mark in every single whole number. That means there's a tick mark at -50, at -49, -48, -47, etc., all the way up. That seems a little ridiculous. Maybe at this point it would be a better idea to have it go by 5s. So I'm going to have it put a tick mark at every 5 numbers. So at -50, at -45, -40, -35, and so on. Again, that's just for aesthetics. It doesn't need to be done. It will still graph the function regardless of the tick marks, but now that's good. We can see the peak. We can see where it bottoms out on the right side. That looks like a pretty decent graph. So again, we don't want to use like the zoom in or zoom out, because as it turns out, we wanted to extend downward much further than we wanted to extend upward. So the zoom in, and we didn't want to adjust the x-axis at all. I mean, if anything, we could maybe trim a little bit of the x-axis off and maybe bring it inward so we don't have to extend quite so far. But I don't think that's necessary here. So the zoom in and the zoom out aren't really all that good, because they're going to zoom in all 4 directions or zoom out all 4 directions. And that's not necessarily the way you want to go. In fact, a lot of times we'll make adjustments to the y-axis pretty often, but the x-axis we might leave alone fairly often. So it's better to make those window adjustments manually, I think. Okay, now, what's the purpose of this? Well, first of all, until we talk about how to actually get the graphs of these functions by hand, we would have no way to look at the graphs, which, as we already know from looking at domain and range, the graph can be very helpful with that. In fact, when it comes to range, the graph is the only tool we have at this time for finding the range. So being able to look at the graph and look at a good picture of it is certainly very helpful. We also now, we're talking about increasing and decreasing functions and extrema. So it might help to be able to see these things. In fact, the extrema in particular, the calculator can actually find those for us. Now, we can see where it is. We can see that there is a local maximum up here, or that there is a local minimum down here. But what are the actual coordinates? Now, we could take a wild guess. I mean, we could say this sort of looks like it's peaking, well, I don't know, maybe somewhere just between -1 and -2. It's hard to really say. And what the y value is, well, be careful. Remember, this isn't counting by 1s anymore. It's counting by 5s. And that looks like it might be about 15, but can we really be sure it's 15 and not 14? Worse yet is this one. This one is further away from both axes. It's much, much lower than the x-axis here, and it looks like it might be somewhere around x equals 3, but it's hard to tell exactly. And as for the y value, this one doesn't even, pretty obviously doesn't even line up with the tick mark. So how can we really be sure what the x and y values here are? Well, fortunately, the calculator has a tool for doing this. Now, there's a button on the calculator that you should never ever use because it's very bad. The trace button. The trace button seems like a really good idea because if you think about what tracing means, what it's actually going to do is allow you to put a cursor on the graph and kind of walk it around by pressing the left or the right arrows. And at the bottom of the screen, it will even tell you the ordered pair. And at first, that seems really nice. Like, hey, check this out. It's on 0, 0. All I have to do is walk the cursor up towards... Oh my, look at those X and Y values down there. Those are ugly. Oh, those are horrible. That is just downright awful. In fact, it doesn't even look like we're ever going to hit a whole number. Like, they're all disgusting. Just no matter where I'm going, they're just awful. Well, that's why you never use the trace button. The calculator is using pixels. You'll notice this isn't a smooth curve. It's kind of bumpy. The calculator is using pixels. Now, the newer calculators have a better resolution, but the older ones have definitely much blockier resolution. But even still, this just isn't very good. The problem is that the trace function is using the pixels. Yeesh. Now, this is a legitimate point on the graph, but who would ever want to use an ordered pair like that? So, we're never going to use the trace button, but if you look right above it in blue, or if you have a TI-84, I believe it's yellow, it says Calc. That Calculate menu has got all the stuff we need to find information about a graph. So let's hit the second button and then go into that Calc menu. Now there's a number of things that the calculator can find for us from a graph. You know, the graph has to be, you have to have actually put in the equation and made the graph to get these things, but it can certainly find a number of things for us. Some of these are fairly self-explanatory, fairly self-evident, like minimum and maximum. Even an intersect, although that would be for looking where two graphs cross. Those two at the bottom look weird. You know, if you ever take calculus, you'll get a chance to use them. But for now, the ones we want to look at are the minimum and the maximum. I'm going to start with the maximum because that's the peak that we come across first. Now, you have to be careful here. You have to make sure you choose the correct one. If you are looking for a maximum point, you have to choose maximum. And if you're looking for a minimum point, you have to choose minimum. Now, look at what it says on the screen here. It's got the cursor on the graph. It's got the cursor at that disgusting point we had before, but it's asking left bound. The calculator needs to set up a range of values to look at. Actually, this is much like how in the definition of a local extremum, we talk about how there has to be the extremum for it to be the highest or lowest point. Well, we have to define that interval around it. So we have to pick a point that if this is where the maximum is, we need to pick a point that is somewhere to the left of it. How fortunate for us, our cursor is already there. All you have to do is press enter to select it. Now, the newer calculators, the color ones, will print a little line there, kind of showing you, hey, here's off to the left. The older calculators won't do that, but they will have the arrow there. Now, you'll notice it asks for the right bound. Well, if we're going to tell it the left side, we got to tell it the right side as well. So just press the right button, keep on pressing it until you go past the maximum, and you start coming down the other side. Hit enter to set a right boundary. Now, from whether you're looking at the arrows or whether you've got the dashed lines there to look at, the whole idea is that when the calculator looks for the maximum, it has to stay in between these two things. Now it asks for a guess. You never know. It's possible that if we set the left and right bounds very poorly, we could encompass more than one extremum. So the guess is about kind of pointing it in the right direction. Since there's only one extremum in between the arrows, the guess is not that important. As long as it's anywhere between the left and right bound, it'll find the maximum. You do not have to go nuts trying to get the cursor exactly on where you think the maximum is. Literally anywhere in between will be fine. In fact, I'll even show you. I'm going to go way past it over here, as long as I'm still within the left and right bounds. I'm going to set my guess way over there and hit enter. And it still found it. Okay, now admittedly, that's quite the ordered pair there. But it's reasonable. This is maybe not the nicest thing in the world, and if you can ignore the 5 there at the very end, it's basically negative 1.6 repeating. The y value is just awful. Not much we can do there. But the point is that we now know the x and y coordinates of this extremum, whether they're friendly or not. Now, we can repeat the process to find this minimum off to the right. So we again go to the calc menu by pressing second and then above the trace button where it says calc. This time we choose minimum. It's going to ask us for the same information as before, but this time we're targeting this down here. So as long as we pick a left bound somewhere on the left side of it, it doesn't have to be close. Close is good, but it doesn't have to be super close as long as it's somewhere to the left. Hit enter to set it, and then somewhere to the right, and hit enter to set the right bound. And as long as our guess is somewhere in between these two, does not even have to be remotely close to the actual value, all we have to do is hit enter, and it will take us there. Now this is a much friendlier point. What's that 6 doing way out there? Now here's an interesting thing. Some of you guys might not have this. Some of you might have 2.9999995 or 3.0000002 or something like that. Why are they varying? Why are they so weird like that? Why isn't it just 3? Well, actually, it is supposed to be just 3. I'm not going to get into the computer science lesson here, but because of the way the calculator has finite memory capacity, but some of the decimal values we're working with are very, very long, sometimes there's a little bit of round-off error. Sometimes it rounds a value because it just can't fit all the decimal places in its limited memory. And when it does that, and then it uses that rounded value to do something else, it causes that answer to be off by just a tiny, tiny bit. So if something is this ridiculously close to a nice value, you can assume it is the nice value. So if this was, say, a test question, you could say that the minimum occurs at x equals 3. For the other one, the maximum, remember it was negative 1.666666, and then I had a 5. You might have a negative 1.66666668. It's negative 1.6 repeating. So again, if it's that close to something that would be a friendly value, it's probably the friendly value. But I mean, it's got to be really close. Like if this came out to be 3.6, not good enough. If it came out to be 3.06, still not good enough. This 6 is so far out to the right, it barely has any impact anymore. So if it's off by that tiny, tiny, tiny little bit, it's all right. You can go with it. So the calculator can graph functions. We can adjust a window to suit our purposes. We can find the extrema, the minimum and the maximum of a function. Now, the calculator cannot find intervals of increasing and decreasing, but there is, as the lesson showed, a connection between increasing and decreasing and extrema. So now that we know where the extrema are, we can actually define the intervals for increasing and decreasing from that. Like, for example, the function is rising from left to right until we hit that extremum of negative 1.6 repeating. So we could say that the function is increasing from negative infinity to negative 1.6 repeating. Once we pass that peak, the function decreases. It falls from left to right until we reach this minimum. So on the section of the x-axis from negative 1.6 repeating up to 3, the function is decreasing. And from 3 onward, the function is once again increasing. So we can use the extrema. We can find the extrema pretty easily. I mean, if nothing else on a graph, you can usually just point and go, ooh, there it is. And now with the calculator, we can find the exact x and y coordinates. And if we know them, we should also from there be able to identify where the function is increasing and where it is decreasing.